So if you recall, the IARPC 2022 through 2026 research plan established the monitoring, observing, modeling, and prediction foundational area to integrate and improve monitoring, observing, modeling, and prediction efforts across the entire IARPC enterprise. One of the specific goals of the MOMP under Objective 3 is to support coordination and engagement with federal, international, and non-federal partners who are conducting work in the Arctic. Specifically, under MOMP 3.3, we are committed to coordinating our efforts with relevant U.S. Interagency groups, such as U.S. CLIVAR, to identify priority activities to support the Arctic component over system predictability and research and development strategic framework and roadmap. U.S. CLIVAR, or the U.S. Climate Variability and Predictability Program, is a national research program whose mission is to foster understanding and prediction of climate variability and change on intraseasonal to centennial timescales through observations, modeling with an emphasis on the role of the ocean and its interactions with other elements of the Earth system. Today, I'm thrilled to have James Morison from the University of Washington and Applied Physics Lab, and as you mentioned, also the Polar Science Center. His research focuses on the study of the Arctic Ocean change using remote sensing to track Arctic Ocean circulation and freshwater distribution. He'll be presenting to us on a recent U.S. CLIVAR-sponsored workshop on observing, modeling, and understanding the circulation of the Arctic Ocean and subarctic seas on behalf of the rest of the scientific organizing committee team that was Dmitry Dukovsky from NOAA NESDIS NCEI, Allison McDonald from Woods Hole Oceanographic Institution, Mary Louise Timmermans from Yale University, and Patrick Heimbach from the University of Texas at Austin. Probably all familiar names to most of you, given your careers. Jamie will present for 20-25 minutes and then leave us ample time to ask questions and discuss the outcomes from the workshop, as well as the way forward since maybe progress that's been made since that workshop. With that, I'd like to turn it to Jamie to present on the workshop. Jamie, the floor is yours.
Okay. And let's see. I think we want this guy. Okay. Well, thank you for this opportunity to talk about our workshop and some of the findings of the workshop. I'll go into things in the first half that were pretty much covered in the workshop, and then we've added a few things for the very end that kind of give an update on some of those findings. I want to thank the CLIVAR, first of all, the agencies that fund CLIVAR, and Mike Patterson and Sam Coakley, who were involved heavily with conducting the meeting and working on the report. And of course, I wanted to thank my colleagues on the Science Organizing Committee, Mary Louise, Dimitri, and Patrick. Okay, the workshop had three themes. The first is basically, what do we think the Arctic Ocean circulation is like, and how has it been evolving? The second is to look at any gaps in our observing system that we need to fill in order to understand the changes in the Arctic Ocean. So that involved a kind of a review of the existing capabilities and the big improvements that had been made in observing. And then we had quite a long discussion of the amazing new modeling capabilities and model-based analysis that we're now capable of. And I'll touch on those all a little bit, but I'm mainly going to talk about the understanding part and observations. The discussion and the workshop was motivated by kind of our perception of the kind of the gross character of Arctic Ocean circulation. And for a long time, commonly you'd see a description of Arctic Ocean circulation, which looked something like this one from a paper by Carmack et al. And it features basically a large anticyclonic Beaufort gyre and a transpolar drift. And over on the kind of the eastern part of the Arctic, kind of an inflow into that transpolar drift. And then over the last 30 years, in situ observations have revealed a freshening and intensification of the gyre. And that's led a lot of discussion that kind of focused around the idea that the circulation as a whole had become more anticyclonic or clockwise in its rotation. And this is an example from a workshop back in 2015 that concluded that the region had been dominated by anticyclonic circulation for the past 16 years. So really going back to about year 2000. But based on subsequent work that was discussed at the workshop and this monopole sort of view of circulation was kind of concluded to be misleading. And in fact, Arctic Ocean circulation has become more cyclonic. So to kind of understand this for people that aren't too familiar with it, I'll just point out that when we talk about the atmosphere and we talk about a low pressure system or a high pressure system, there's a particular sort of circulation that goes with that. And for example, if we have a kind of a cylindrical model atmospheric low pressure system, that drives through geostrophy, it drives a clockwise circulation in the atmosphere, which creates a clockwise stress on the ocean and characterized by negative stress curl. And that causes Ekman convergence, which pumps up the surface. And so we get convergence and doming in the ocean and this sort of mirror clockwise circulation in the ocean. And then just the opposite happens in the case of a low pressure system. The low pressure drives counterclockwise circulation in the atmosphere, which drives Ekman divergence in the top of the ocean and sucks the surface down so that we get surface depression in the ocean and a counterclockwise circulation there. So, and we think a better understanding of kind of what's been going on, it results if we take more of a dipole view of the circulation of the Arctic Ocean. And this is a bigger cryosat-2 dynamic ocean topography or sea surface height. These are contours from a paper by Fu et al. And it was in Ron Kwok's presentation at the workshop. And so in this picture, we see you've got the familiar Beaufort gyre kind of in the western part of the Arctic and the North American part. And then over on the Eurasian side, we have this counterclockwise circulation or cyclonic gyre, Eurasian gyre. And I think this picture is quite nice too, because it also shows that there's in some sense, it's better to think of the Arctic Ocean circulation as involving the subarctic seas just at the outset, because that cyclonic circulation is part of the cyclonic circulation in the subarctic seas. And between these two counter-rotating wheels, we have the transpolar drift. So in this sense, we like to think of the Arctic Ocean circulation as a dipole of these anticyclonic and cyclonic gyres. And then the sense of circulation is related to the relative strength and size of the two gyres. And there's a kind of a theory for that that goes back to one that was advocated in a review by Sokolov, 1962. And this really was brought to the attention of the West. I mean, I'm talking about North America, by Andrei Proshetinsky in his paper with Mark Johnson. And he was kind of the first to let us all know about this notion of cyclonic and anticyclonic modes. And in this theory of Sokolov, the mode A is the anticyclonic mode, and under a strong Beaufort high, it features a large Beaufort gyre and a rare narrow region of anticyclonic circulation along the Russian coast. And then mode B is what we're calling the cyclonic mode. And under a strengthened Icelandic low that spreads into the Arctic Ocean up to the New Siberian Islands, according to Sokolov, that basically shrinks down the Beaufort gyre and expands that cyclonic circulation over on the Russian side, with a transpolar drift shifted towards North America. And we can think about that change in forcing in modern terms. We can think about it in terms of the Arctic Ocean, the Arctic Oscillation Index. And that's a characteristics of the atmosphere. The mean sea level pressure over the northern hemisphere, north of 20 north, is shown on this figure on the left. And it features a large, in the Arctic, a large anticyclonic Beaufort high. That's the mean. So if we subtract that sea level pressure off and we look at variability, the Arctic oscillation is the name for the pattern that accounts for the most variability in the northern hemisphere sea level pressure. And it has a really, as the name suggests, it has a very Arctic character. The AO pattern is in the positive phase, intensifies the Icelandic low and sort of extends it up into the Arctic Ocean to the New Siberian Islands, similar to the language of Sokolov. So a positive AO forces increased cyclonic circulation on the Russian side of the ocean and reduces the Beaufort high in atmospheric pressure, at least in size, and it implies this cyclonic mode of Sokolov. And this is a picture that's sometimes I look at it and it sort of looks like the story of my professional life, but I'm going to point out this is the principal component time series for the Arctic oscillation, and here it's divided by the standard deviation in the AO. So we'll characterize it that way. And there are a couple of key features that we'll talk about. Prior to 1989, the AO was on average in a slightly negative phase. And then in 1989, there was a major transition, and the maximum AO was reached in that year. So there was a strong shift in the cyclonic sense. And then over the 1990s, the AO kind of declined and reached kind of typical pre-1989 values in, for example, 2003. And things kind of rattled along down there in the more pre-89 realm until we come to 2007, in which you got another big jump in the AO, a 2 sigma jump. The picture's a little confused because then in 2010 we reached a minimum AO, and but that bounced back after just a year. And what we find is that there's been basically a 1 sigma increase in the average AO after 1990. So there's really been 2 phases in my lifetime over the course of that 70 years or more, in which we've had this sort of slightly negative phase prior to 89, and and a slightly positive phase after 1989. Now, this is a figure that I think, I don't, maybe Larry Hinsman remembers, but at one point about 20 years ago, I think I showed this figure to the IARPIC when we met in a big room at the biggest conference table I ever saw that was at NSF. And I was trying to explain what had happened in that first event, 1989 AO maximum event. And the data comes from the cruise of the USS Pargo in 1993, which we cruised around the Arctic Ocean and made CTD stations. And it was a very fortuitous track. This figure you see is salinity anomaly relative to the EWG atlas of pre-1989 conditions. And it shows a salinity perturbation, mainly in the central Arctic around the North Pole and down across the Makarov Basin. And this whole thing, we argued, was associated with a shift in the front between Atlantic and Pacific derived waters from a frontal position roughly over the Lomonosov Ridge prior to 1990 to one over the Alpha Mendeleev Ridge in 1993. This figure that's just popped up on the right shows the RMS salinity variation from the US-Russian climatology in the 1970s. And it shows the same pattern. In other words, this is sort of a natural mode of variability, this flopping back and forth. But this change that we saw in the 90s in the Pargo data is about 5 times the RMS variability in the 70s. The other one that comes up quite a bit is 2007. That jumped back up to two sigma units. When you first look at it, and this is kind of the most interesting part of the workshop, when you look at that, you see this is a figure that shows ISAT dynamic ocean topography in the Arctic Ocean and down into the subarctic seas, and it shows a big bulge there in the Beaufort Sea, which is the Beaufort Gyre, the big red thing, and you see that in the previous to 2007 dynamic ocean topography, the Beaufort Gyre is prominent, but it actually gets more intense as we shift over to 2008, 2009. So the Beaufort Gyre, if we look at that, especially if we just look at in situ observations concentrated in the Western Arctic, you really get the sense that this whole event was a shift towards a more anticyclonic circulation. But then if we look at the difference between the two, in other words, we look at the change, then that looks more cyclonic, because although the Beaufort Gyre in part intensified, it also got smaller and it got kind of shoved down towards the archipelago. And meanwhile, this big trough of sea surface height decline appeared over on the Russian side of the Arctic Ocean. And that's pretty much exactly what the cyclonic mode consists of, where you have this depression, cyclonic circulation on the Russian side, and we're coming to appreciate intensification on the North American side. If we put the dynamic heights from the US-Russian Atlas together with the ISAT and Cryosat-2 dynamic ocean topography records, we can see some important features. And in the first place, this figure shows on the left the vorticity or rotational sense of the circulation, taken as the Laplacian of dynamic ocean topography. And then on the right, we have the same thing, but for the satellite altimetry data of DOT. And the main thing is that the Beaufort High vorticity is actually greater in the later period, 2004 to 2019, than it was in prior years, 1950 to 89. So reinforcing this notion that, well, things have gotten more anticyclonic. But the other part of it is that the part that's the eastern part actually also gets stronger. So there's more stronger cyclonic circulation in the Eurasian basin, and that part of the circulation actually gets bigger. So what happens then, we can look at the average vorticity change over the two periods, and consistent with increased AO forcing after 1989, the average vorticity actually increased from minus 15.4 to minus 2.4 times 10 to the minus 10. And the area of positive vorticity increased from 42% to 55% of the ocean. So even though the Beaufort Gyre region became more anticyclonic, overall, the average circulation became more cyclone. Let's see. Okay, and then if we can also take those two records and perform a empirical orthogonal function analysis. We concatenate the records, or we can analyze them separately. We get kind of the same picture if we analyze the previous record and the satellite era record. But we get something like this, where the primary shape, the primary variability, has this shape, EOF1, and it really emphasizes that that circulation change is centered in the Makarov basin. It's this big, in the positive phase, this EOF is negative in a kind of a big cell there in the Makarov basin. And that's really kind of consistent with that picture we had from the Pargo analysis that looked at the RMS variability in the EWG atlas. But it's important that though the Beaufort Gyre is not a central feature in this, it does intensify whenever the dominant mode becomes more cyclonic. So again, we have this kind of dipole character where the cyclonic mode shows up as more cyclonic circulation on the Russian side of the Arctic, but also it intensifies the kind of eastern part of the Beaufort Sea anticyclonic circulation. This is a principal component time series for EOF1 shown in the magenta, and along with a blue line there, that's the kind of the first order filtered AO that's lagged 1 year, and we got the best correlation between the principal component 1 and the lagged AO, and you can see that both of those kind of jump up and down at those important points like 2007 and 1989, and the minimum in 2010, and they have a small but significant correlation between that lagged AO and the PC1, and both the AO and the PC1 show an increase after 1990. So it's reflecting this regime change that occurred after 1990. Okay, so thinking about models, boy, I was really impressed at the workshop with the way models have changed, being a kind of an observationalist and not seeing that all the time. It really, and I think about the days of PIPS was the ocean model, and for the Navy and what they have now, it's just incredible how much the resolution and stuff have improved. And now the reanalyses make the most out of measurements by using models. And it seems like that's just changed and improved by orders of magnitude. And there are these 4D VAR DA systems that'll permit attribution of changes in relative important quantities using spatially and temporally distributed observations. There's concern that was expressed on the part of the modelers that they were maybe using out-of-date climatologies, which I think might be true, depending on what the climatologies are. They were concerned with using the continuum models of ice. That's a long-standing concern. And there seems to be a tendency for the models to produce salinities that are too high. But there weren't a lot of discussions of simulating actually this AO response or the response to 2007, or certainly not to 1990. But there were some things, and one that I thought was pretty interesting was one by Wang, and they've used the German model to look at the changes in circulation are in response to a change in AO, and what we find is that they have the control is on the left, kind of a neutral AO zero case, I guess, and then in AO negative, which is the middle panel, you see that under a negative AO, the model shows the Beaufort gyre expands to nearly fill the basin. And then under an AO positive situation, again, this cyclonic trough kind of expands over there on the Russian side, and the Beaufort gyre contracts and shoves itself up against the archipelago. So this AO positive case is like the cyclonic mode of Sokolov, and the AO negative case is like the anticyclonic mode of Sokolov. There have been several papers that have come out about the change in 2007, but one of the earliest model results was actually in Cecilia's dissertation. And I don't think, sorry, Cecilia, I don't think we paid enough attention to this at the time. But it's pretty interesting when we look back on the other things that we saw at the workshop. This was, first of all, she's plotted up the positive wind curl on the Russian side. Well, it's wind curl plotted for the basin for summer and winter, and then for all months. But interestingly, the positive wind curl on the Russian side of the Arctic Ocean increased over 2007. So what you're seeing here are plots of 2007 to 2011 minus the averages from 2002 to 2006. So again, we get this increase in positive wind stress curl or wind curl on the Russian side, and a decrease or more anticyclonic forcing in the Beaufort Sea area, especially up against the archipelago. This one shows the echo and the biomass results for sea surface height, I think, and ocean bottom pressure change. So sea surface height are the top two, and for echo and biomass, and then ocean bottom pressure, those bottom two. But it's pretty consistent with the curl. The model DOT show a deepening trough on the Russian side of the Arctic Ocean because of that positive stress curl, and doming in the eastern part of the Beaufort Sea. And to go along with that, this is the freshwater content. This behaves pretty much like what was observed. We find that the modeled freshwater content decreases on the Russian side over the 2007 transition. And while at the same time, freshwater content increased in the Beaufort Sea. Well, again, this is another example of why why we need to look at this dipole character. Uh, this was a period, we're considering a period from 1990 really to the present, in which the Beaufort gyre seemed to get stronger, and particularly after 2007. But at the same time, this result from Kenningson and Timmermans, it was in Mary Louise's presentation at the workshop, that Beaufort High actually got weaker, as indicated by all the blue bars that occur after 1990 in the upper plot. And they relate this to an increase in the Nordic Sea cyclone activity index, which kind of goes just the opposite. So it suggests that we've got more cyclones coming in from the Nordic seas, and it indicates that the Beaufort High has gotten weaker, which, if we take just the simple view, that seems inconsistent with the Beaufort High becoming more intense. So that raises the question, can a positive AO in the cyclonic forcing of the cyclonic mode somehow strengthen the anticyclonic Beaufort gyre? And yes, and there's a couple of reasons, one of which has been talked about quite a bit before, and which I think is really important for a lot of reasons. And that's, yes, that the diversion of Eurasian runoff Eurasian runoff basically is diverted by that cyclonic mode to go along the coast of Siberia and get all the way to the Beaufort Sea. And for example, in 2007, pre-2007 versus post-2007 chemistry sampling, we found that the big increase in freshwater content and change in dynamic height was associated with an increase of Eurasian runoff down in the picnic line. So I think that that's important dynamically, and I might get a chance to talk a little bit about why it's important in terms of our environment. But so that's one reason. And then, but the end of it, that's got sort of a 1 year-ish, maybe 2 year time lag to it. And we've also seen examples that it can be shorter. The time lag between an increase in the AO and an increase in the strength of the Beaufort gyre. Sarah Dewey, I think my only graduate student that's not on the call, she found that there was with a 2-month lag, the strength of the Beaufort gyre in the summertime correlated best with the 2-month lagged AO. So how can this thing happen so quickly? Well, in part, it's just how we think about a low pressure system. And when you think about it carefully, I showed just a simple spinning disk of atmosphere in those first slides. But when you think about it, if you've got a low pressure system, for example, as shown here on the right in kind of a schematic cross section, that has this sort of counterclockwise twist to the atmosphere. And that has a positive stress curl associated with it. But there's always a tail to allow the atmosphere to settle off to zero, to ambient conditions, off away from the low. So this sort of ring around the positive stress curl area of actually negative stress curl. So there's this sort of halo of opposition. And that, in this sort of schematic argument that you see in part B of the figure, would have a dip under the heart of the low, and then an actual kind of halo of raised sea surface height on this halo around the low. And the same thing applies for a high pressure system, except it's just reversed with a dome in the middle and then this sort of moat of like halo around it of depressed sea surface. And we can kind of see this as an example. This is this is well, we've got the atmospheric, the AO pressure pattern, the loading pattern of the AO on the left. And again, it's this sort of lobe of low pressure that extends into the Arctic Ocean. And then what's plotted on the right is the curl of the wind speed associated with that pressure pattern. And what you see is, well, gee, there's this sort of big, big negative spot, excuse me, it's positive spot. We've done it in blue. We've got kind of a reversed color scale, but the blue indicates positive curl and the red negative curl. So the blue positive corresponds to a depression of the sea surface and more cyclonic circulation, and the red corresponds to an actual elevation of the sea surface, but it's a negative stress curl. And so what you see is that all around this sort of center low that goes up from the Nordic seas into the U.S. Russian side of the Arctic has this halo of red. And I should add that land doesn't figure into this. So in a way, it's sort of inaccurate when we talk about convergence and divergence. There's, as far as the stress in the ocean and Ekman transport, things in that halo tend to get amplified by the fact that there's a coast. So we have to I don't have a simple model of that, but anyway, so the positive wind stress curl shows up in the Makarov Basin, but we get negative wind stress curl in the eastern part of the Beaufort Gyre, Beaufort Sea. So that's going to tend to build up. This whole pattern will tend to kind of erode the western part of the Beaufort Gyre, but build up the eastern part. Okay, let's see. Where are we? Yeah. Okay. Existing observing systems. This is the scary part. The observing systems really improved, and we've got all kinds of new instruments for getting at things in finer detail in the in situ situation. And remote sensing is really improving. We've got ISAT-2 coming. Well, ISAT-2 is here. SWAT is coming. And this remote sensing has revealed circulation over the whole ocean, which is a huge improvement. And those tools, I can certainly speak for ISAT-2. The resolution of that thing it's going to be fantastic, and well, that's a whole nother talk. But the problem we see is, in spite of all these advances, the existing in situ observing system has this Beaufort Sea bias that misses the cyclonic mode. So this is that plot of the EOF1 of the circulation. So it shows the major feature sitting there in the Makarov Basin, and then kind of the red periphery, which is, I would argue, part of that halo that we see associated with the AO. But along with the EOF is plotted from Ignatius Ringer the percent chance of finding an International Arctic Buoy Program buoy in any 250 kilometers square based on the buoy tracks measured from 2001 to 2021. And the scary part about it is the probability contours roughly align with the EOF contours, actually to a remarkable degree. But they're such that the odds of finding a buoy inside EOF1's dominant feature are less than 10%. And the odds of finding a buoy inside the Beaufort Sea are 30 to 60%. And part of that is our focus, what we think is important and what we focus our measurements on. But another part of it is natural, in that cyclonic circulation tends to diverge buoys, the ice spreads apart under cyclonic forcing, and the ice tends to converge under anticyclonic forcing. So the Beaufort Gyre kind of naturally is going to get more buoys hanging around than buoys you put out in the Makarov Basin. But the problem there is, and this was pertinent to this main question we had, the EOF is such that the vorticity indicated by this small, better sampled Beaufort Gyre is the exact opposite of the rest of the ocean. And I think that's a big part of why the circulation has looked to many of us like it was more anticyclonic, when in fact it was, if we could look at the whole thing, use our remote sensing tools, we could find out what was really going on, and we'd see that it had become more cyclonic. Okay, so recommendations. Well, I think we need a program to better understand the circulation change that includes observations over the whole ocean and the subarctic seas, and modeling and analysis that goes back in time. There's not very many models that go back to the prior condition prior to 1990. So I'd like to see more of that. Anyway, this whole effort will involve modeling and model-based observing system design for surface circulation and freshwater content. Satellite remote sensing can give us those over the whole basin. But for ground truth and for the deeper circulation change, we're going to need more in situ hydrographic observations in repeat sections across these critical regions. And a key ingredient for reaching these remote regions will be, I think, coordinated use of military assets for civilian research. For example, the SciSix program, the Medea and EWG effort to bring military informally classified information into the civilian science world, and produce things like the U.S.-Russian Atlas. We have a Scissors program, which uses U.S. Coast Guard aircraft to do hydrographic sampling, and ICE PPR. And that's I think it's the International Cooperative Engagement for Polar something research. Got it written down here. But anyway, and there's some present examples of this that are really encouraging. Right now, as I'm talking, Ignatius Rigger is out deploying International Arctic Buoy Program buoys from an Alaska Air National Guard C-17 under the ICE PPR program, and I'm sure he's putting a bunch of buoys there to try to fill that sparseness gap in the Makarov Basin. And then there's this. I think we made a lot of progress observing the Makarov Basin and the cyclonic mode in 2023. For example, we ended up putting some Nav-Oceano Alto floats on the Healy for the Healy's crews to deploy and recover NABOS moorings and do their hydrographic work. And so we got three Alto floats, profiling floats that got in there, and one of the profiles is shown on the right from that location there, shown in the figure, the chart, and it shows, interestingly, it shows really profiles that don't look like they have much Pacific water in them at all. The salinities are elevated, a couple of salinity units relative to the EWG climatology. The EWG climatology are the little circles with dots in them and the straight line connections, and the Alto floats from September 2023 are the solid line. So we see elevated salinity just like we saw back in 1993, 30 years earlier. And if we look at the dynamic heights, the figure that you see on the left shows the chart of contours of dynamic height from the EWG atlas averaged from 1950 to 1989. So this is that same climatology we were compared to with the Pargo data. And indeed, the Pargo dynamic heights are shown on the Pargo track as these colored dots. And so the color scale is the same for the dot, the station averages, as the contour plot of the EWG climatology. And you can see what we saw in the Pargo data before, this basically this trough extends across the Makarov basin. But we see almost is that the cyclonic mode, just like in 1993, the cyclonic mode is still in place. Well, anyway, that's just to say that I think this is going to be the key, how to do things over in that region. We're going to need to take advantage of the big military assets, aircraft and ships, and put those together with civilian science. Well, anyway, thank you. I want to thank the workshop folks. This will be about 50 years I've been working on the ice, and I just want to say thank you to all these agencies that have supported me all this time. It's been fantastic. I couldn't ask for anything more. I think we ought to thank Al Gore and Linda Zoll and the Medea folks. You know, as I look back on it, we wouldn't really know where we were except for their efforts to release this formally classified data. And it sort of illustrates what happens, what we can do when people at the highest levels decide that we want to do it. It just opens all kinds of doors. And if they hadn't done this, we'd sort of be lost. We would only have a perspective that goes back 20 years. And I think that perspective is really important. And I'd like to thank all the people that have helped me. So that's it. Oops, now I'm into backup slides.
Thank you so much, Jamie. It's been an amazing presentation. And Hazel has said this in the chat, but we're bumping up against our time. But if folks are able to stay on, I'm happy to stay on as well so that we can get some questions and discussion on, because I think this is really important, important work. And I think this workshop has actually really improved our understanding of Arctic circulation. So if we can, maybe we turn to some questions from the group here online. Does anybody feel like starting? And if you're not feeling particularly bold, then you can also put something in the chat, and I'm happy to share any comments and questions. And if not, I will ask. So this workshop happened in late 2022, Jamie. What has happened since? Obviously, I see that there's been pretty intense communication with Ignatius, which is entirely great and appropriate. But what has happened since 2022?
Well, we worked on the organizing committee worked on a report, and I thought that was really important. I actually I learned quite a bit working on the report and going back over everybody's talks. Somebody comes and gives a talk, and you're breathing through or drinking from the fire hose, and you need to go back and look at the presentations to actually see, oh yeah, now I picked up all kinds of stuff. For example, it wasn't too much on the atmosphere. I saw one participant here is is interested in the atmosphere. But there's and Jennifer Francis gave a talk, and there was a little bit of other discussion, but I've actually found some figures in her talk that really got me thinking about, well, what's the role of the Arctic oscillation in global warming, and in particular in Arctic amplification. So we're kind of working on that, but we're not doing that as part of the workshop, but it's just an example of the kinds of things that popped up. And we've worked pretty hard on this this notion that how did we get these two views competing? And so this sort of simple idea of what the character of this halo of negative stress curl around the positive stress curl core of a low, that kind of came about just by looking at the problem and thinking about this conflict that seemed to be there and really isn't there. Anyway, and so we've got the report, but something that a problem I think was that CLIVAR had all kinds of workshops they had basically put off because of COVID, and they all kind of happened at once. And so the all I know is we turned in a draft workshop report, and I haven't seen the official one come out yet. So I don't know if they've decided they've just got to move on or what. But so that's all I can say there. I'm kind of working on trying to write a review paper, and I thought we kind of had a pretty good consensus, and but there's some things that maybe people don't agree with, so there's always this kind of stuff going on. But I hopefully we'll have some sort of BAMS review that's at least inspired by the workshop. As far as Ignatius, I mean, a bunch of us, are just kind of plunging ahead, trying to get measurements over in the Makarov Basin. And we've been trying for a couple of years to get over there with our Coast Guard flights, dropping, we work with the Kodiak, Air Station Kodiak, Coast Guard station, and fly with their C-130s out over the Beaufort, and we're trying to get up the approvals and stuff to go, instead of right out across the Beaufort, to swing over and go a little bit, well, it would be northwest and go across the Makarov Basin. But that's a little bit of a stretch logistically. And Ignatius seems to have tapped into this ICE PPR C-17, and with the C-17, you can pretty much go anywhere and drop an amazing number of buoys from the C-17. So that may be the path that goes. I'd like to see a kind of a revival of SciSex. There were some problems for a few years of it was something about the mechanism they had for declassifying the ICE draft data. And I think that they now have that figured out. I saw email from Jackie Richter Menge that said that they thought they had a solution to the procedure for declassifying that information. It's largely an issue of the location of the submarine versus time, and how do you sort of make that sanitized so it's not a security issue. And I think they've got that squared away. So there may be some more activity on that. But really, I mean, I think it'd be great to have, when I talked to the IARPC before, it was really to promote this idea of the study of environmental Arctic change, or SEARCH. And that was originally envisioned as, in at least for me, as sort of the equivalent to the study of IMSO, because we'd seen this big change of the AO and we'd seen all these changes. And at the time we were thinking, well, maybe this is a decadal kind of change. But then, as I said, in the 90s and early 2000s, the AO dropped off. And then as I was told, they kind of dropped the AO part of it, that whole decadal change from search, because the AO had dropped off and yet all these changes had persisted. And I think there's a reason for that. And I think the reason is, in spite of the AO dropping off, that big surge, basically that changed the whole character of the ice cover. And I kind of get that, as much as anything, I get that from just my experience being on the ice. I can look at my life experience on the ice prior to there's 20 years prior to 1993 of going out on the ice, and then the 30 years since then, and it's just different. I mean, the previous period, we were always dealing with multi-year ice, and we had camps on thick ice, and we searched around for refrozen leads to land a plane on. And then in the last 30 years, it's gotten more and more to be, well, you fly around and there are plenty of refrozen leads to land on. And boy, if you see any multi-year ice, it's a real surprise. And, it's just such a fundamental change in the character. And I think there's a paper by Ron Lindsay and Jinlun Zhang talking about a tipping point. And they talk about that big change in the early 90s with the high AO as something that sort of flushed the older ice out. And I don't think the ice has had enough cold winters to really grow back to that status. And so I think that was premature. I think it was premature for us to say this was decadal variability. I think looking back on it now, I think it was a regime shift. And in order to understand how that's going to evolve and what the implications are, I think we're having to adapt our observing system to go with that. So, I guess that's why I feel that part of it is most important.
That's really insightful. I think I'd strongly recommend. I'm happy to reach out to Mike too and push him on the on finalizing the report, because I think that's a really important thing to get out onto the streets. I also wonder whether any of the contributors are comfortable with posting the presentations from that meeting, because it sounds like that is an incredible body of information. Yeah. And finally, I'd also really strongly put in a plug for that BAMS review article. I think that would really help pave the way forward and get a lot of visibility. And I'm very curious, actually, since you mentioned sea ice, whether there's also been any work to connect and compare the observations that you have that you've presented with and compare those with what the ice was doing on a particular year and what the cold pool was doing on a particular year, to sort of correspond with those observations and connect them with observations of what the biology was doing before and after. Yeah, I think there's so many massive implications for what you're doing.
I think those are really good comments. I think particularly that connection with the ice and the ice and the atmosphere, because part of this switch to the cyclonic mode, again, in a cyclonic forcing, the ice tends to diverge and you get lower ice concentration. And I think the implications of that are big. In other words, we're saying that here's a whole chunk of the Arctic that's being more divergent in terms of its ice motion. And so we're actually just starting to kind of try and look at, can we correlate what's first, it's complicated because of seasonal variability, but is there a good way to correlate changes in concentration with the AO, for example, or with any index? And we have this sense that under a cyclonic mode with a high AO, you're going to tend to have more divergence in the ice cover over on the Russian side of the Arctic. And if one of the figures that Jennifer Francis did not show, but was in her collection, showed the pattern of warming, of Arctic amplification of temperature. And guess where that pattern is centered? It's kind of over the Makarov Basin. And it's really looks like another image of the AO pattern. And there's some other reasons to think that the AO would participate in Arctic amplification, but I'm really interested in how much divergence and reduced ice concentration has to do with it. Because are we letting all that heat come out of the ocean because you've got more leads and that kind of thing? So it could be that the ocean is making a contribution to that Arctic amplification. And the biology seems like the biology would be different. When we were first starting out in search, if you look at some of the old search literature, we had a bunch of references to things that had changed around 1990. I became fixated on looking at people's data and presentations for changes that occurred starting in 1990. And I don't know what's happened since I kind of got away from search, what's happened to the biology end of that. But I think there's got to be some impact. I think we don't have too much. Maybe no presentation from the Navy here, but I'm sure that the acoustics environment has changed too. An important, which I think would be important to the Navy. I think one thing that I was most concerned about is back in the late 80s, early 90s, kind of before this got going, the Navy, ONR got, or I forget it was ONR, got tasked by Senator Ted Stevens with figuring out the fate of radionuclides from these Russian dump sites. They had these tremendous processing plants, nuclear material processing plants in Siberia, and they all have waste ponds that really are connected to the groundwater in the Russian Arctic, and they all drain into the Ob and the Yenisei rivers. And so the concern was that we'd be getting radionuclides from those and radionuclides from Russian submarines and reactors that they would dump in the Kara Sea and the Barents Sea. And so the Alaska Native community said, come on, Ted Stevens, are they poisoning us? We people that do some subsistence hunting and stuff like that, are we getting radioactive seals? And so he tasked ONR with this nuclear waste assessment project. And so a bunch of ships were cruised around and they sampled for radionuclides, and they kind of found, well, gee, most of it seems to come from the Saalfeld plant in England. And then the argument was, and this is a key environmental issue too, I mean, in terms of global warming, but as part of that cyclonic mode, what we found in the 2007 related data was that all this water that we were finding, fresh water increase we found in the Beaufort Sea, really it was Eurasian river runoff. And the circulation pattern is such that it carries the runoff along with other coastal waters along the coast of Siberia to the east until it can get really all the way to the Chukchi Sea. And so, but at the time we did this nuclear waste assessment project, the argument was, well, besides, any of that nuclear waste is just going to go directly from the Ob and the Yenisei and the Lena rivers right out into the North Atlantic. So the people in North America, the native communities of Alaska, don't have to worry about it. Well, if we're in a cyclonic mode now, that changes the complexion of that. So any kind of pollution that Russia produces, we have to think seriously about it in the cyclonic mode. We have to think about it coming to Alaska. So there's that environmental aspect to it too. And then, well, Mike published a paper with Tim Boyd, and he demonstrated that Russian runoff, which normally had gone into the halocline and stiffened the cold halocline, under the cyclonic mode would be going to the Canada basin. And so he predicted a weakening of this cold halocline, and they found that in their 1998 paper. And since then, Igor Polyakov has kind of studied that several times with his NABOS project and written several papers on that. And he terms that Atlantification, in which you basically get warm Atlantic water closer to the surface. So that whole part of it is, I think, important climatically. I probably went on too long.
No. I mean, I could talk to you all afternoon. I just, I worry that I might have kept you a little bit too long for the purposes of this meeting, and want to allow people to go back to their days. But I first want to say thank you so much for being willing to talk about this. I'm going to chase the final report from U.S. CLIVAR, and I hope that we can also, if you'll indulge us, maybe have another engagement with a broader IARPC community too, because I think that, again, the findings of the workshop itself, as well as the implications for the modeling community and the observational community, as well as just the expanded insights for the physical oceanographic community, it's just massive. And I think this is really really important workshop, and I'd love to see more, and I'd love for others to see more of this.
Yeah, well, I'd love to talk about it. It's, like I say, it's kind of occupied the last 30 years of my career. So that, along with NASA satellite altimetry, have kind of become my main things.
Oh, what an amazing body of work. Yeah. So with that, I'll thank you again and say that this is not anywhere near done. The recording will be available soon on IARPC Collaborations, and I will look forward to collaborating with you further and finding other ways to give more visibility to I think this really important work.
Thank you. That'd be wonderful.
Okay. And with that, I'll let Brian, unless you're coming off of mute. Did you want to say something?
Just I added to the chat 2 URLs to the Naval Undersea Warfare Center, which has detailed information about the 2022 ISEX mission to the Arctic. It's fascinating, the measurements they're taking, and some of them may be of interest to the speaker.
Thank you. That's the 2022.
Yes.
They were kind enough to put out a buoy for us at I-6 22. And I think we're a little bit involved with 2024 as well. That's a great program.
Well, this article summarizes much information and excellent photographs.
Cool. Okay.
Thank you.
Thank you.
Awesome. Thanks so much for sticking around, Brian, and thanks for your comments and your questions. And I'll probably see you at the board meeting tomorrow afternoon for USA on. So hopefully we'll be able to get some be able to talk about this some more too. Okay. So let's go ahead and close the call. And again, with my sincere thanks. I will look forward to more. We'll find a path forward, and I'll approach you once again to see how we can continue to build on this.
And I'll get Hazel the presentation.
Awesome.
Okay.
Thank you once again. Have a great day.
Bye-bye.
All right. Bye now.